in this next example, we're going to find a composite function and its domain. So suppose that f of x equals x squared plus 2x minus 5 and g of x equals 3x plus 1. Find the function and its domain. So f composed of g would be written as f of g of x. And we're going to take, and what we're going to do is we're going to place g of x, the function 3x plus 1, in where the g of x is within the f of g of x. And the next step would just be to replace 3x plus 1 wherever there is an x in the f of x equation. Okay, so we would end up with 3x plus 1 squared plus 2 times 3x plus 1 minus 5. And then what we're going to do is we're going to square to get the answer. And then don't forget to do the distributive for the second one to get 6x plus 2 minus 5. And then we are going to simplify. So the composite function for f composed of g is 9x squared plus 12x minus 2. So one thing to note is that the domain of f is all real numbers, and the domain of g is also all real numbers. So that tells us that the domain of f composed of g is going to be the set of all real numbers. And this is because the domain of both f and g are all the set of real numbers. So let's flip it. Let's do g composed with f. Same thing, except for this time g is on the outside, f of x is on the inside. And what we will do now is we're going to replace f of x with the x squared plus 2x minus 5 in the g of x, and then now we're going to replace the x in the g of x function with x squared plus 2x minus 5. And then we're going to distribute the 3 and then simplify. And that tells us that g composed of f is equal to 3x squared plus 6x minus 14. And like the previous example, both g and f are the domain of, has the domain which is the set of all real numbers. So once again, the domain for this composite function, g composed with f, is going to be the set of all real numbers. So in this next example, find the domain f composed with g if f of x is 1 over x plus 4 and g of x is 4 over x minus 3. So one thing to note is that the domain of g is x except x cannot equal 3. And the domain of f is x except x cannot equal negative 4. So this means that g of x cannot equal negative 4. So we're going to look and make sure that g of x cannot equal negative 4. So if it cannot equal negative 4, that means what is my x value then? Because that's what we're going to have to exclude, because we're not excluding the negative 4, we're excluding the x value that would go in for g of x. So we want to solve for g of x equals negative 4. And first thing we're going to do is we're going to place in the 4 over x minus 3 for the g of x, and we're going to set that equal to 4. And then we are going to multiply both sides by x minus 3 so that we can get rid of the bottom of our fraction. And then the rest is just simply figuring out it algebraically, and we end up with an answer of 2 equals x. So therefore, x equals 2 is also excluded. So the domain of f composed with g is x except x cannot equal 2 and x cannot equal 3. And that would be our two solutions, or that would be our domain for this composite function. In this next example, in finding a composite function its domain, we're going to look at some rational functions. Find the domain of f composed of g if f of x equals 1 divided by x plus 3 and g of x equals 3 divided by x minus 2. So the first thing is we're going to look at the domain of f. Okay, and the domain of f is x except x cannot equal negative 3 because we can't have 0 on the bottom of a fraction. And the domain of g is x except x cannot equal 2. So first, let's look at the domain of g, and as we stated, x cannot equal 2. So this is excluded from f composed with g. So we need to remember this is excluded from our composite functions domain. Second, we want to look at f composed with g as a function itself, where we combine both of the fractions together. So f composed with g of x is equal to f of g of x, and we are going to replace the g of x with 3 over x minus 2 and then place that into our f of x function. And we end up with 1 divided by 3 over x minus 2 plus 3, and then that simplifies into x minus 2 over 3 plus 3. And for those of you that are not sure how we got to this point, all I did is I multiplied the top and the bottom by x minus 2, because anything divided by itself is 1, so we're not changing it, we're just proportionally making it the same. So 1 times x minus 2 is x minus 2. 3 over x minus 2 plus 3 is going to be multiplied by x minus 2, so you need to make sure and remember to distribute that. So that'll cancel out the x minus 2 on the first fraction, and we end up with 3 plus 3 times x minus 2 on the bottom of our equation, as you can see up at the top. And then we continue on from there. We're going to distribute the 3 times x minus 2, and then we're going to use the distributive property because 3 is in both areas or both terms, and we're going to do the distributive backwards, and we end up with x minus 2 over 3 times x minus 1. So that means x minus 1 must also be excluded from the domain. Okay, so our domain for f composed with g is x except x cannot equal 1 and x cannot equal 2. Finding a composite function its domain. In this one, you can take a function and do a composite function with itself. So find the domain of f composed of f if f of x is 1 over x plus 3. So the first thing we'll do is we'll know that the domain of f is x, where x cannot equal negative 3 because we cannot have a 0 on the bottom. So f composed with f of x is f of x. And we're going to take and find f of 1 over x plus 3. So we just took our f of x and placed it where the x was, and then now we're going to do our equation. 1 over x plus 3, and just like we did on the previous example, in this case you would multiply the top and the bottom by x plus 3 over x plus 3, and that will get rid of our fraction and leave us with x plus 3 over 1 plus 3 times x plus 3. Keep simplifying by distributing and then combining, and our final composite function is x plus 3 over 3x plus 10. So on the bottom we take and we see that x cannot equal negative 10/3. Remember, this is because 3x plus 10 cannot equal 0. So therefore x cannot equal negative 10/3. So our two exclusions are x cannot equal negative 3 and x cannot equal negative 10/3. So the domain for f composed with f is x, except x cannot equal negative 10/3 and x cannot equal negative 3.